Top 10 Space Discoveries 2022 finally revealed. 2022 was a good year for astronomy. Images raining down from the James Webb Space Telescope continue to dominate the news cycle. We were treated to not just one but two total lunar eclipses. Artemis 1 launched and the DART spacecraft crashed, on purpose. And astronomers unveiled the first image of the behemoth black hole at the center of our galaxy. But it's not all roses and starshine. The National Science Foundation has decided not to rebuild Arecibo, and NASA discontinued the SOFIA Airborne Observatory. New satellites continue to crowd the sky, and they're getting brighter, not fainter. Light pollution, too, continues to grow. Here, we look back at the biggest news stories of the year. Science is such a forward-looking endeavor that it's all the more rewarding when long, challenging efforts finally come to fruition. And 2022 was a year with many payoffs, as researchers began unlocking the secrets of our solar system's asteroids and received rich maps of the stars that populate the Milky Way. Excitement reigned as we moved an asteroid from 6.8 million miles, 11 million kilometers, away. New and intriguing phenomena popped onto the scene, proving we still have much to understand about our universe. And two groundbreaking stories stole headlines, as we finally glimpsed the monster black hole at the heart of our galaxy and received the first stunningly sharp images from humanity's most challenging and risky space telescope effort to date. It was also a year for reflection, as landmark missions drew to a close. Yet even as opportunities end, others are waiting around the corner, and astronomers are always ready to seize them. 1. James Webb Space Telescope. Arguably the biggest and best news of 2022 has been deployment of the James Webb Space Telescope and the deluge of images that followed. Fanfare greeted the release of the initial pictures, and within days Webb had already broken records set by the Hubble Space Telescope earlier this year. Since then, Webb has continued to supply us with jaw-dropping views of newborn stars, dying giants, swirling galaxies, and worlds far closer to home. This is only the beginning. JWST has much to teach us in the coming years, but it will take some patience. Capturing images is one thing, analyzing them is another. The discovery of the most distant galaxies known, now confirmed by spectroscopic observations, might require us to rethink our ideas of galaxy evolution. And exoplanet data will take time to fully understand. 2. Artemis 1 heads to the moon. After touch-and-go wet dress rehearsals and months of delays, the first test flight of the Space Launch System and Orion capsule went off without a hitch. Artemis 1 launched successfully and completed its trajectory, returning some stunning vistas of Earth and the Moon from a vantage point we haven't seen in quite a while, before splashing back down in the Pacific Ocean. On its way, the mission also released 10 CubeSat missions to various orbits, with mixed results. 3. Two total lunar eclipses. Not just one but two total lunar eclipses greeted skygazers this year, with the second one combined with an occultation of Uranus. We won't see another total lunar eclipse until 2025, with only partial and penumbral events until then. See S&T's online photo gallery for a fine selection of image submissions from both of this year's events. 4. Crashing into an asteroid, on purpose. NASA's Double Asteroid Redirect Test, DART, mission successfully hit Dimorphos, the moon of asteroid 65803 Didymos, in a test of planetary defense. Not only was the impact successful, but so was the redirection, as ground and space-based telescopes recorded a significant 32-minute change in the asteroid's orbits. Astronomers are still analyzing stunning images of the purposeful collision and its debris to fully understand its impact on the asteroid system. 5. An image of our own black hole. 3 years ago, astronomers revealed the silhouette of the black hole that lurks at the center of nearby galaxy M87. This year, we finally got the chance to see our own galaxy's central beast, SGRA. The Event Horizon Telescope team took its time in releasing its silhouette because, well, it's complicated. First, to see SGRA*, astronomers had to peer through the dust and gas that enshrouds our galactic center. And even once they penetrated that veil, they knew the gas falling in toward the black hole would be whirling around the 4.3 million solar mass behemoth in a matter of minutes, rather than days as in the case for M87. The image was worth the wait. Turns out, SGRA is full of surprises. The infalling gas was unexpectedly calm, and it seems to have clumped up, though exactly how many clumps and where is still up for debate. Astronomers will be working to understand SGRA* for years to come. 6. Mars mesmerizes. The opposition of Mars on December 8 meant the red planet was once again big, bright, and beautiful in the evening sky. It wasn't quite at its closest point, That happened the week before, on December 1st. But this year, opposition brought with it a special kind of magic in the form of an occultation behind the moon. The perfectly round orb contrasted beautifully with the shadowed craters of the moon, resulting in some unforgettable observations and imagery. 7. Planetary decadal calls for mission to Uranus. The planetary science community has come up with its prioritized wish list for the next 10+ years in the field, a document that will help decide what missions NASA funds. Top of the list is a flagship mission to the ice giant Uranus, for now called the Uranus Orbiter and Probe. The full report comes in the form of the National Academies of Sciences Planetary Sciences and Astrobiology Decadal Survey, titled Origins, Worlds and Life, a Decadal Strategy for Planetary Science and Astrobiology 2023 to 2032. It's the third prioritized wish list of its kind. As always, any mission concepts will still need to go through rounds of funding, design, and development before reaching the launch pad. 8. Low Earth orbit satellites are getting brighter. Satellites are being launched to low Earth orbit at increasing rates, leading to an ever more crowded sky. While SpaceX initially worked with astronomers and developed a sunshade to help dim its Starlink satellites, it has since discontinued the sunshade. As a result, the Starlink satellites have become brighter again. They are still dimmer than the original design, with an average magnitude of 5.6. Meanwhile, an even greater worry is facing astronomers. The AST Space Mobile Aerospace Company has launched a satellite named Blue Walker 3, which now shines brighter than most stars, at magnitudes between 4 and 0. The satellite is a prototype for the Bluebird satellite constellation. Its members will have even larger panels and will thus be even brighter than Blue Walker 3. 9. The final flight of the Sophia Airborne Observatory. Though expected, the final observations by the Sophia Observatory, which flew for years aboard a modified Boeing 747, represented a loss for infrared astronomy. In our coverage, we reflect on the gains Sophia has provided over the years, including the discovery of water on the daylit moon and the first type of molecule to form in the universe, as well as the reaction from the community. 10. A new way to see the local bubble. Astronomers have long made the case that supernovae blew out the local bubble, a cavity of sparse, hot gas around the Sun. This year, a team of astronomers has gone further, determining the local bubble's origin in time and space. Tracking stellar motions back through time, they concluded all started some 14 million years ago, when between 14 to 20 stars in the upper Centaurus Lupus and lower Centaurus Crux clusters went supernovae. The Sun now sits nearly at the center of the local bubble, but that's happenstance. Our star was 1,000 light-years away from the supernovae when the fireworks began and entered the local bubble only some 5 million years ago. Subtle bubbles like this one might fill the galaxy. The survey also includes the first State of the Profession, discussing diversity and equity in planetary science and astrobiology. While acknowledging progress in these areas, much work remains to be done, in particular to address persistent and troubling issues of basic representation by race, ethnicity. Recommendations in hand, it is now time for funding agencies to decide where and how to allocate resources in the coming years. Like, comment, share and subscribe to my channel.